Hey guys, happy Monday. First of all, let me say I hope everybody saw my post on Friday about some opportunities for making up some credit from before spring break, knowing that all of this e-learning stuff is only 5% of your grade. And I say only, but as you know, 5% can make the difference, can actually affect your grade. So make sure that we're doing the e-learning stuff, but also if you did poorly on one of the tests or quizzes before spring break, make sure you do that future plans extra credit assignment because, or not extra credit, but the future plans test remediation assignment basically can take the place of up to 50% of the points that you missed on your lower test score. So, if you got 60% on a quiz and that was your lowest score, you can bring it up to an 80% by doing well on that assignment. That'll really help your grade. Also, if you're missing any of those Google Doc assignments from the reactions unit, make sure that um, that you that you do those and turn them in. Originally, our policy says you're not going to be able to turn them in this late, but just because we're not going to be able to do more labs or add things to the lab grade category, it's very important that I give you guys the opportunity to make up those huge points that some of you guys failed to turn in. So just go back through Google Classroom, find the assignments from part A, part B, whatever you're missing, um, finish them up completely, and resubmit them because they were handed back to you. You should be able to resubmit them. If you never handed it in, you should just be able to submit it for the first time. Email me if you have any questions about that. Okay, so getting on to acid-base indicators. This is actually our last topic in our acids and bases unit. Obviously, I'm not going to be able to give you like a traditional test. What I'm going to do is when we're done with this, I believe I think I'm going to assign it on Wednesday. Or no, I'm sorry, after today. So part of today's assignment is going to be to to do a quizzes, um, and you'll be able to do it, open note, obviously, because you're at home, and try the problems multiple times, all that good stuff. But I will put in a grade for accuracy. And again, it's not like a test because it's open note. Also, because you can answer the questions multiple times, um, and try to improve your score and all that good stuff. But it will go in for accuracy, unlike most of the rest of the grades that I'm putting in during this e-learning phase, which are just a completion. So okay, so back to acid-base indicators. So this is kind of an interesting concept, but it's pretty simple. Um, we have these things both in nature and in the lab that can actually tell us chemically through color change whether a solution is acidic or basic. So I have up here in purple, and you don't need to write down the charts or the images that I'm going to show you, but just what's in purple here. Common indicators like litmus, if you've ever heard of litmus paper or a litmus test, that is referring specifically to the acid-base indicator litmus. But there are a ton of them: bromothymol blue, methyl red, phenolphthalein, and all they do is they change color in a solution, like let's say lemon juice. You put some acid-base indicator, some phenolphthalein into lemon juice, and it's going to turn color. Um, and in the case of phenolphthalein, if you look down here, um, see it right here, you notice that it changes from colorless to pink, and it does that transition at a pH of about 9, which, do you remember whether that is acidic or basic? Okay, so yeah, 9 would be basic. It's above 7. So the cutoff is right here at 7. So if you put some phenolphthalein into lemon juice, lemon juice is acidic, like most fruit juices are acidic. Um, that pH is going to be somewhere down here around 4, maybe 5, just depending on how the strength of it. And so that means the phenolphthalein is going to be colorless. If you put it into, dish soap or or window cleaner or drain cleaner, something that's got a higher pH of around 9 or 10 or 11, it's going to be pink. And so that's phenolphthalein can be used to indicate whether something is acidic or basic. And so can the rest of these guys. And you see here that they all transition in different places. So if you really wanted to see whether something was, if you wanted to see something changing from acid to base, like let's say you were neutralizing an acid with a base. If it started out acidic, and you wanted to know the moment that it turned basic as you poured the base into the acid. Let's say the base was baking soda and the acid was vinegar, and you wanted to know the instant that it turned neutral. You put in little teaspoons of baking soda slowly. You're going to be bringing the pH from acidic more and more towards neutral. And if you have some bromethymol blue, because it changes from yellow to blue right at about 7, it would be a really good indicator for that reaction to know just when you were turning from acid to base, because it changes. Here's yellow, here's blue, and you might have like just a slight bit of green in between that that would indicate that the pH was right at 7. And then once you put in enough to make it totally blue, then you would know that it's on the basic end of the scale. That's what an indicator does, okay? Now, we also have universal indicators, and universal indicators are helpful, like if you're testing pool water to see what the pH is. It won't just tell you that it's above or below a certain number. It'll actually give you the specific pH, or at least, within reason. So, for example, if you have pool water that the pH has dropped down to 6, it's going to turn yellow. So not only do you know that it's acidic, you know that it's not super acidic. It's not like orange or red, which would indicate, 5 or 4, but you know specifically that it's around 6. So that's what and a universal indicator is just a mixture of a bunch of these other indicators. Okay, so how does this work? What's happening here? It's not magic. It is simply that an indicator itself is a weak acid or base. So what's going on here, and I don't know where that H came from. I think I just accidentally typed it. Okay, there we go. An indicator, and this HIN is just a generic way of saying indicator. So you've got the HIN molecule. And I used IN because that just, it's like short for indicator. So basically this is a molecule that has an IN part to it. And that IN might actually be a very large complex molecule, but it's got this H attached to it, okay? And so when you put it in water and dissolve it in water, you can kind of see, hopefully you can see what's happening here. So where is that H going? That's out in front of the HIN molecule. Okay, so hopefully you can see that the H is being given to the water, and the result of that is the water becomes what? Yeah, the water becomes hydronium, and it leaves behind just the IN minus. Essentially what we've done is we just chopped off the H, right? Okay, so that's not a big deal. That's what happens in just about every acid-base reaction. What makes an indicator unique, what makes this thing unique, is that before and after it loses that H, it's two different colors. And that's what makes it an indicator. Any acid, when you put it in water, is going to lose its H, just like this one is doing. But the thing that makes this an indicator, whether it's phenolphthalein or bromethymol blue or whatever, the thing that makes it an indicator is that it's two different colors with and without the H. Whereas most acids are just, clear, colorless. So, for example, maybe it's yellow when it has the H, and then maybe it becomes this like pink or lavender color after it loses it. Well, if that's the case, then you would know whether the solution that indicator was in was acidic or basic by the color of that indicator. Another cool place where this actually shows up, it shows up a lot in nature actually. The video that you saw in the CK12 reading showed you the guy on the little news show dropping cabbage juice into different solutions like lemon juice and all that stuff, and changing colors. That's a natural acid-base indicator. It's just like our universal indicator that I showed a second ago, only it's naturally occurring. Um, Another one that's interesting is if you've ever seen this flower before, you might have it in your garden, or maybe you've seen it in somebody else's garden. This is called a hydrangea, and the interesting thing about a hydrangea is it has acid-base indicator in its flowers. So you can see here that we get a couple different color flowers, and actually, if you look at the little thing down below, if you plant a hydrangea, in acidic soil, so pH below 7, you get a pink flower that eventually blooms. If you plant it in basic soil, you get this purple flower. So if the pH is, let's say, 7.5 or 8, if it's neutral, you actually get sort of like a combination of the two. And so that tells you your soil's pH.